Hello guys, it is research series, and in this session I want to teach you how to perform linear regression. And what is linear regression? Linear regression is used when you want to measure the effect of one variable or several variables on a quantitative variable. The first type is named simple linear regression, and the latter is named multiple linear regression. For example, in this study I want to measure the effect of stress score, disease and anxiety score on depression score. First of all, I choose analyze and then regression. You can also run the test by using generalized linear models, which will be discussed in another session. I choose regression and then linear. As you can see here, I have sent depression here to dependent list because I want to measure the effect of stress, disease and anxiety on depression. Disease can be normal, receiving score 1, or cardiovascular disease receiving score 2, or diabetes receiving score 3. There are some options here, for example, collinearity diagnostics, which will be explained later. I just deactivated it for now. And confidence intervals, be sure that you have chosen this icon to include confidence interval in your results. And plots, you can use these rows to make plots to measure the accuracy and the validity of your test. Now I just simply run the test and show you the results. There's a table here and you can see I have two variables with significant p-value, anxiety score and stress score, both of which are associated with depression score, and they are positively associated. It means that an increased anxiety score will predict an increased depression score, and you can just report it like this in your article. You use this number 3900ths, and 95% confidence interval, and then you must add the lower and upper bound, for example 2500ths and 5300ths. You can also write a prediction model for the depression score using disease state, anxiety and stress, and the constant. The constant shows the bits from the origin in a linear model, and it is 18 in this study. And as the p-value has not been significant for disease, you can exclude it from the model, and anxiety received certain 900ths, and stress received 3000ths slope number. It means that 1 degree increase in anxiety score will cause 3900 increase in the depression score. The line formula can be written like this. So you have a formula for predicting the depression score based on anxiety score and stress score, and you can report it in your article. As you remember, I have told you about the collinearity and also charts for validating your results. Collinearity shows that if there is any specific and strong association between your independent variables. I mean that there may be, for example, a strong association and correlation between, for example, anxiety score and stress score, and it can finally affect my results and change this beta number, and it will distort my results. So to find out if there is any collinearity, I can use analyze and then regression and linear and statistics. I just tick this option and continue. Okay. As you can see, 2 columns have been added here, VIF and tolerance. If VIF is more than 10 in any row, or if tolerance is less than 0.2 in any of these rows, it shows that there is a substantial collinearity which I need to add some modifications. These modifications include increasing your sample size, removing one of these variables, one of those variables which are causing the collinearity, or combining some variables which are showing collinearity and using one unified variable instead of several variables with strong association. Or I can use centralized variables, which is not very useful in removing collinearity, and it is a bit complex and I just want to skip it. And you need also to measure the efficacy of your model. I mean that this model may for example lose some predictions which are residuals, and there are the bugs of the models. You need to measure if these residuals have normal distribution or they are randomly scattered. So you need to again use regression, and they choose linear and plots. You put one of these first 2 rows to y axis and the other one to x axis, and you also select histogram and normal probability plots, and then continue and OK. Some plots have been added here, one of which is a histogram, and it is nearly showing a normal distribution pattern. And the QQ plot, if the dots are located on the line or near it, they show a normal distribution pattern. In this case, they are nearly showing a normal distribution pattern, and these dots in this chart must show a random pattern, and you can't conceive any specific pattern, or you can't draw a line between them. As you can see, my model is quietly good, and I can report my results. If you enjoyed this video, please don't forget to like, subscribe and comment. See you soon.